Yeah, the recording is started. So now this session is going to have two topics. One is hyperparameter tuning, how we can do that easily, not like a cumbersome task. And the next one is fast API. So that's like a Python framework we are going to use. Okay. So let's start with hyperparameter tuning. So there is no theory is there. So only two terminologies there. That is, one is GridSearchCV, another one is Randomize Search CV. Okay, what are those things? Okay, so grid means, like a tabular structure, some rows and columns are there. So that way, okay, let's see, let's go directly jump to practical so that it will be easy to describe. So just think, like, if we have this data set only, iris flower data set that we already saw, correct, previously. So we will load those data, we will check what are those data are there, okay, that we check. So this is very simple, we know. Now we are train and test split that we are doing, that is also same. And we are implementing a SVC, like SVM model, okay. And we got 91% accuracy directly. What we used kernel as RBF, C hyperparameter is 30, gamma is auto. So we already know C and gamma is basically two hyperparameter tuning we have to do. So we got. Now on top of that, we can easily do K-fold cross validation like CV5 that we already learned. And we have to play with this hyperparameter. See, first time we are using linear C10 gamma auto, second one RVF C10 gamma auto, RVF C20 gamma auto. So this is like a cumbersome task, correct? Like individual line was you are changing your hyperparameter, correct? So another approach that you can do, you can create a for loop, like for loop within another for loop, and you can pass manually these two lines, kernel, because two type of kernel we are using, RVF and linear, and C is like 1, 10, 20. So then what will happen? It will give me when RVF 1 means RVF kernel and C equal to 1, so 98, RVF 10, 98, RVF 20, 96, linear 1, 98, linear 10, 97. So this is one way you can do manually, correct? You can create your own loop and you can do that. But is there anything that this same thing we can do easily, correct? So then we are going to introduce GridSearchCV. So grid means you already got, like we have kernel and C like in an array, like a row and column, and we are searching based on individual points, correct? So what I need to do again, scikit-learn model selection GridSearchCV. In that GridSearchCV, we need to pass like this way. See, okay, so this is my model, gamma equal to auto, that I'm not going to change, that will going to handle by scikit-learn itself. And I want to play on top of C and my kernel, else everything is same. Then if I doing this instead of that manual for loop, what will going to happen? It will give me, let's see, like this way, individual. Now again, can you read this? You can, but this is very difficult to read. So what is happening? GridSearchCV, okay, result, that object is basically returning in the form of data frame. So you can easily collect this frame via Panda. So if you are connecting the result, okay, as a data frame, so see, you got a table, like this tabular structure. From here only, you can easily get, correct, like which one is your best parameter for C, best parameter for kernel. How? Because you have score over here. See, same score. All the scores are kept, correct? Now, if you want to just focus on this three part, because that's my end target, you don't need others data. So just, you know how to select particular index. So you are just choosing those index or columns and see over here, you easily get, correct? Like this is 96, 96, 97, 98, 98, 98. So if I am using C1, so no matter I am going via RVF or linear, both will be like giving me 98%. If I am going 10, then it will be RVF only, because linear time is giving 97. So it's a bit less. or you can just write like this way, my best param. Okay, it will return you which one, and choose best code, it will return you best code. Simple, very simple. So use like this way, you can play around with your hyperparameter tuning, correct? You can play with your model selection, you can play anything, but GridSearchCV is bit slow. Why? If you suppose here instead of C 3 points, you can, there is no limit, correct? So you can give any amount of points like 1, 10, 20, 50, 100, anything. Then what will happen? Obviously the performance will be slow. Then another technique is there that is called Randomize Search CV. It will take as a randomly, okay, but the output will be same. Cool. Now, as I told, like this is like a train and test error. Okay, you don't know like which model is going to work perfectly. So this is for SVM, this is random forest, this is logistic regression. So for SVM, you passed your model and parameters. For random forest, you passed your model and parameters. For logistic regression, you passed your model and parameters. Okay, so this is like a basic JSON structure that you created as a model param. Now, what you need to do, you just create a for loop, right? Because that JSON structure you only created using GridSearchCV or RandomizedSearchCV, whatever you want, no issue. Okay, you just pass the model and param over here. So single loop, it will pass one model and one parameter. Model is this one, parameter is this one. Okay, and when you fit your model, and you need to append model base code base parameter like this way. So then what will happen? It will return you in a very structured way. See, SVM 98%. C when 1 and kernel is RPF. Random forest 95%. N estimator 5. Logistic regression 96%. C equal to 5. So from here only you can easily decide for this iris data set. Okay, SVM is working prominent way, 98% accuracy. That's huge. And your best parameter, that is 1, C equal to 1, and color is RPF. So previously we learned individual algorithm. Then we saw like how individually you can test. Now over here, we are implementing how you can choose base model and base parameter. That's why it's called hyperparameter tuning, because you are tuning. Correct? Okay. So that's all done for machine learning part. In machine learning, there is nothing else. Okay. Rest of the thing we are going to learn like NLP, deep learning, and other stuffs. So let's jump to our next topic, that is FASTAPI. Okay. What is FASTAPI? You guys know, you guys maybe heard that name. Yeah. Can you guys just unmute and turn on your camera once so that I can know, like you guys know that thing or not? You guys already heard that like Django, Flask, Jinja, correct? So we are not learning those things, anything. Okay, we are directly jumping in FASTAPI. Maybe this term you never heard. Why? Because Django 3.0 implemented, okay, you know, asynchronous stuffs. But if you are going for 1.0 or 2.0, there is nothing like asynchronous. Okay. Now, Flask obviously not support asynchronous. Jinja just like a template, a structure. But FASTAPI, the name itself is saying is fast. Okay, this is like a high performance, very easy to implement. Okay, very easy to implement, and It's have a very beautiful document kind of structure because things behind it's using Swagger. Swagger, you know, correct, for documentation and for your API. So see, it's look like this. Okay, so if I am running this one, so it will look like this, or I can run like this way also 127 docs. So if I'm writing docs, so it will come like, so you can play around, okay, with your, you know, those APIs and other things. And this is totally asynchronous first. So two new things today we are going to use when we will build that end-to-end model. One is FASTAPI and second is pydantic. Okay, what is pydantic? Pydantic enforces types to hit at runtime, provide user-friendly error when data is invalid. Means for creating a class or your base model, it will going to help you so that through your API, no one can send whatever they want. So you can validate. Okay, so this kind of help you will going to get pydantic. So pydantic, see, very simple, like this base model I'm importing. Okay, I'm creating a class. So let's jump fast. Okay, with that practical one, then it will be very easy. But before that, if you can, you know, in Google search only, simple thing like fast API versus, because maximum people, okay, they are using these two things only. Like they compare and they work in practical work. Now, if you can do that, um, let's go to image directly. Let's open this image. See, this is like a chart, like, you know, see, where is Django? Over here, below the table. Okay, Flask is there also, but few modified version like raw and other things there. So two famous thing that we are going to use in future. Today we will use FastAPI, and in future maybe we will use this Starlet. So Starlet and FastAPI almost same. Few changes are there. So that's why we choose this FastAPI so that we can use a very fast and high performance API structure. Okay, and we will use today UVCon. So today we are going to learn FastAPI and UVCon. UVCon is like a you know, Node.js server, okay, or you can say uh, PM2, which actually helping you can run FastAPI. So that is UVCon. So this is like a two new thing. Whoever don't know Python for them. So but very easy. If you know Express.js, okay, you will easily understand FastAPI. There is nothing, absolutely nothing. Okay, and pydantic is basically helping us to validate those data. Data validation, setting management, these things are happening through pydantic. Okay. So I'm stop sharing my screen. Okay, right now. And as soon as possible, like within 1 or 2 minutes only, join you guys again, the last link. So do not waste the time. Let's start actual end-to-end implementation that will going to help you. Okay, so we will spend time over there. Then if we have time, then we will do question answer also. Okay, so let's jump in the next recording session. Bye bye.